In this chapter, we're going to talk about different ways to display data. The first one we're going to talk about is a scatter plot. A scatter plot is a graph that shows a relationship between two different quantities, or two different data sets. The two sets of data are graphed as ordered pairs on a coordinate plane, so very similar to when we made our graphs of linear equations earlier this year. But as you can see from a scatter plot, we don't have something that's a nice linear looking line. It's not nice and perfectly straight. The scatter plot is showing the amount of fat in this next example and the number of calories in 12 restaurant sandwiches. So we want to just kind of look at what is this really telling us. So down here on our x-axis we have the grams of fat. You can see our scale is increasing by 5s. On our y-axis it shows the calories that is going up. Notice that the scale is by 50s. And notice also that we have a little break here from 0 to 300 to kind of show that we've jumped into this 300 to 800 range. So we also have the title of it up top to make sure that anyone that looks at our graph knows exactly what they are looking at. So now we just want to answer some questions to interpret what we see. So the first question basically says how many calories are in a sandwich that contains 17 grams of fat? Well, if I come down here to 17 is sitting someplace in this range. Looks like it kind of comes to this point, and that would match up with 400 calories. Part B says how many grams are in the sandwich that contains 600 calories? Well, the 600 calories would come across to hit this point, and this point coming straight down would tell me 30 grams. So what tends to happen to the number of calories as the number of grams of fat increases? Well, remember, the grams of fat increasing along in here is getting bigger. There are more grams of fat that way. And during that same time period, if you kind of look at what's happening above, we can see that while those are going bigger, we also see these seeming to get bigger as they go as well. So what tends to happen, based on what the picture is showing, is that as the number of grams of fat increases, the calories increase as well. Which kind of makes sense. As the fat grams get bigger, calories would also increase. But that's what the graph is showing. It's not a nice, perfect, steady slope, but there tends to be an increase as it goes. So what if the sandwich had 650 calories? Based on the scatter plot, how many grams would you expect the sandwich to have? Well, if I look at the grams of fat and the 650, so 650 is this line, and if I come across, it seems like I get something pretty close to there. So this is where we're going to kind of interpret what we see and kind of estimate a little bit. I would say that 650 calories would be about, 32 grams. Somewhere between 32, 33 grams. So here's a kind of scatter plot overview. The scatter plot can show a relationship between two different sets of data. The way it shows it is in several different ways. Here in this first picture, we see a positive relationship, or a positive linear relationship. Not linear in the sense that we see a nice straight line if we connected the dots, but this looks very similar to something that is climbing as the x's are increasing, y's are also increasing. The points are pretty close together. We can say that that's a positive linear relationship. It's almost like the slope is positive. So then we have a negative relationship. So in this case, it kind of looks like if we could draw a line straight through it, it would be a negative slope. In this case, as my x's are increasing this way, you can see that the y's are decreasing as they go. This would be a negative relationship. Sometimes we have this thing called a non-linear relationship. We know that none of them are really linear, but this one definitely has some sort of a curve, which is definitely not straight. And then the last one would be is no relationship. We kind of see a whole bunch of scattered points bouncing all over the place. There's really no pattern, so we just have to say there's really no relationship in that information. So here I've kind of set up my graph, and it might be a little bit different than how you might have set it up. And a couple little features I want to show you here before we start plotting points. I did tens. I jumped over because my pen is a little bit harder to write on this, but you might be a little bit more careful on yours. I just did 10, 20, 30, 40, 50 across for the study time in minutes. On here I did my little break to jump up to 60. Reason so is I noticed that most of our numbers were from 60 to 97. So I don't really want to have a bunch of numbers that are covering 0 to 60, which is the big range, when I don't have any. And then by going by twos, it allows me to get a little bit more accurate on some of these points. So now I'm going to try to plot these points and to see what they look like. So if I go to 30 and I come up to 80, that is the first point that we would plot. 20 and 74 would be another point here. 60 and 92 would be right there. 90 and 97 would be right about there. 45 and 85 would be sitting right in the middle of that one roughly. 10 and 62. 30 and 83. 75 and 90. 120 and 70. And 80 and a 91. So there are our points for what this would look like. I obviously went a little bit further than I really needed to on my graph, so you don't really have to do that. But I would say looking at this graph, we now have some information that we want to talk about. So we want to look at what are the things that we're seeing. Well, basically, I would say for the most part, we see a positive relationship. Taking a step back and looking, I think for the most part, we have a positive relationship. There is one that kind of seems a little bit out of whack. That's the one that we're going to kind of focus on here. Here is our outlier. I think based on all the other information that we're seeing, we do have one that doesn't really fit the rest. So the student that studied for 2 hours, 120 minutes, only got a 70, doesn't really seem to fit by studying that much and only getting a 70. So chances are we're going to throw that one out and not be considering it. And once you remove that one, then the positive relationship even is more kind of noticeable. So then we want to look for any kind of a gap. Well, the only gap that I can see is kind of in the range where I see the test scores kind of jump. So I might look at this as maybe a gap from 62 all the way up to 74. We kind of have like a long kind of not much happening in there. 62 to 74. The other ones are all kind of in the pretty close ballpark. They're really not too far away from each other. So you might argue that 62, a big jump up to 74, is a pretty big change. As far as clusters go, I'm not really sure that there's a cluster here. Again, to me, a cluster has got to be at least 3 or 4 more points right on top of each other. I don't really see any here. Certainly people could argue up around the 90s that you have 3 people around that time with about that same numbers. I'm going to kind of go with the idea that I don't really see any. There's really none here that I would say would be strong enough to say we should count it. So basically you can see in scatter plots that we don't have nice perfect straight lines with a slope that is steady, constant rate of change. These are probably more realistic though to when we do comparison of things with data, because not everything is going to be nice perfect lines. However, we still can see positive or negative relationships. Even though they're not perfect straight lines, we can still see trends of how things are happening. In this case, as your studying time gets greater and goes up and increases, typically your scores or your grades get better. So it's a positive relationship. Doesn't always happen, everybody's a little bit different, human nature comes in, but that's where the scatter plot can still give us some good trends to kind of look at and to predict future events. Next, we want to identify these relationships. So describe the relationship between the data. Identify any outliers, gaps, or clusters. Well, let's look at the first one. So when I look at this first one, while we don't see a nice perfect straight line, I think that it's pretty much kind of positive. I would say that we can probably say that this is a positive relationship. It's not perfect, but it definitely seems to be that as the X's are getting bigger or the television size gets bigger, that the price gets bigger. Then we want to look at the outliers and the gaps or clusters. So there's a couple of things on this one. So outliers. Outliers are basically points that don't really fall in suit for the most part with the rest of them. In this first graph, I would probably say this one is a little bit of an outlier. You have a 70-inch TV, which is the biggest TV we have, for only about $2,200. So the outlier, I would say in this case, is going to be the point 70, and again, I don't know, 2250, something about that. Doesn't really fit. It's probably one that we might just throw out and not include in our graph if we were doing more information about this data. When I think about gaps, gaps are just kind of what they sound. Gaps would be as if a bunch of information is all of a sudden really not there. You can argue that there's a gap here. You can say that between 500 and 1500 that there really is a gap in what we're seeing in that kind of price range. So we could say there's a gap between the $500 and $1,500. The prices for the TVs seem to jump from 500 to 1500. And then lastly, we can also look at the clusters, which basically a cluster is a bunch of points all kind of gathered close together. Now in this case, I would probably say there is a cluster that is somewhere down in this range right here. The cluster would probably be between 22-inch TVs and maybe 32-inch TVs. There seems to be a lot of information kind of bundled up and gathered in that spot. There's actually four pieces of data in that one little kind of small range. Actually, it's really not 22, I guess, is it? It's probably a little closer to 25 because we're going by tens. So let me just adjust that. So now we're going to look at the age and number of pets owned. So when you look at this one, we're trying to compare the person's age and how many pets they own. Well, you might kind of think that the older people get, they would have less pets, which is probably true in a lot of cases. But if you look at this graph and this data, there doesn't really seem to be any kind of a relationship that's proving that. Certainly not one that we can definitively say. So this is one of those graphs that we would have to say there is no relationship. It doesn't seem to say that the age of a person gets bigger, that they either have more pets or they have less pets, because there's a lot of different spots that it's kind of varied. On the second part, for the outlier, well, because there's no relationship, we're not really going to say in this case there's really any outlier. You might argue that the one at the very top by itself, but because there's no relationship, there's nothing that's really kind of out of sorts in this one. The same thing with gaps. I would probably say there's no gaps here. And in some cases, the gaps, the outliers, the clusters are a little bit of your opinion, and as long as you can back it up with your explanations and it's reasonable, we can all kind of say, well, I can see that and I don't agree, but I can go this way. It's not as much of a right or wrong answer. When I look at clusters, again, in my opinion of this, there are no clusters as well. There is only 2 points that are kind of close together in 2 different spots, and there's really, to me, a cluster is kind of more like 3 or more points in an area. So these are only 2, these are only 2, so I would probably say there are no clusters in this graph. So next we're going to make a scatter plot. And the scatter plot is basically just taking your data and kind of creating what you have and seeing your points as you go. Obviously what you want to look at is the study time in this case for my x-axis. My test scores are going to be my y-axis. It's going to be important to kind of think about your scales so that you can kind of figure out what you want them to look like. We want to come up with a graph that has strong labels on our x and y axes, good scales, so that we can plot our points as accurately as we can without getting crazy. So I'm going to pause the video and I'm going to have you kind of try your own graph on this, and then we'll kind of take a look at what we come up with.